Okay.
Good morning, everyone. Today
Today we'll start a new chapter which is redox reaction. Okay. So first we should know what is the meaning of this word redox, right? So as most of you have said already, was okay. Yeah. Now it's fine, right? Now it should be fine, right, everyone? Now my voice should be fine. Okay. Yes, it's fine now. Okay, very good, right? So when you talk about oxidation or reduction, right, whatever we have studied in class 10, okay, it was associated with oxygen, right, everyone? It was associated with oxygen, which means the gain of oxygen was termed as oxidation, right, everyone? Right? The gain of oxygen was termed as oxidation, okay, or removal of hydrogen was termed as oxidation. So oxidation, when you talk about classical concept that we have studied till class 10th, right? So oxidation means gain of oxygen or loss of hydrogen, right? This is what we have studied. Yes or no? Tell me, right? Okay. Now, when we talk about some more concepts, right, then the oxidation can also be termed as when a high electronegative atom is added. Okay, right? Like oxygen, if high atom is added, that also is termed as oxidation. For example, when we talk about FeCl2 plus Cl2, so Cl is a high electronegative atom as compared to Fe. Now it is added in FeCl2. So this is also your oxidation. Okay. So oxidation, when you talk about classical definition of oxidation, okay, you can say that it is addition addition of oxygen, right, or addition of higher electronegative atom, or removal of hydrogen, or removal of electropositive elements. Right? Okay, so this is the classical definition of whatever we have studied till class 10th. Now, this is about oxidation. What about reduction? Okay, now obviously reduction would be just opposite of this, which means removal of oxygen, removal of high electronegative atom, addition of hydrogen, and addition of electropositive elements. Yes or no? Tell me, everyone. Right? So this is just the definition we are talking about that we have already studied in class 10. Okay? Right? Now, but what is the actual definition? If you see all the definition, you can just note down one point, that when we are adding a high electronegative atom, we are actually doing what? Tell me, we are giving electrons, right, everyone? We are giving electrons to high electronegative atom. Okay? Right? Got it? Because O2, right? If we give electron, then O2 will become O2 minus now, right? So when you talk about the general concept, so I can say that generally, right? If electron is added, right, in all the four processes, when the when O2 is added, or high electronegative atom is added, or hydrogen is removed, or electropositive element is removed, in all the four processes, one thing is common, which is loss of electron. Loss of electron, right? Guys, please tell your friends to join soon, because most of you, they haven't joined. Okay, got it, everyone? Tell me, yes or no? Tell me that all these four processes, which was defined in classical concept, leads to only one conclusion, that it is actually the loss of electron, nothing else. Okay, it doesn't matter what process you uh, take, right? Be it adding O2 or be it removing hydrogen, right? It's just the loss of electron. Okay, in the same way, when you talk about reduction, when you talk about reduction, this is also the same, which is addition of hydrogen, removal of oxygen, addition of electropositive elements, and loss of electropositive elements, right? So, in nutshell, I can say that the term oxidation and reduction, right, means only loss or gain of electron. Okay, mean only loss or gain of electron. So I can say that, right, if an electron, so that was the classical concept, right? So in modern concept, I can say that if an atom, right, or an element loses its electron, right, loses its electron, then it is called as oxidation, right? That's why I'm having a mnemonics which is Leo Judd, right? I hope most of you remember from foundation class. So loss of electron is oxidation. Loss of electron is oxidation and gain of electron is reduction. Okay, so you just need to know that if an element is gaining electron or losing electron. For example, suppose you have 10 rupees, right? How it is easy. Suppose you have 10 rupees and you are giving and in the afternoon, suppose you have 5 rupees. Now tell me, right? You're gaining or you're losing money? Tell me. You're gaining money or you're losing your money? Tell me. Very simple, right? So you must be like, so what you're asking, right? Obviously, I'm losing money, right? My money is decreasing. But, right? If I won't tell you that you had 5 rupees, if I won't tell you that you have 5 rupees, then tell me, you are gaining money or losing money? Tell me. If I won't tell you what was the initial amount, what was the amount before the change, right? Can you tell me that are you losing or gaining? No, you cannot, right? You cannot tell that either you're gaining or losing. So that's the thing, right? You should know the state. What state? Oxidation state. Okay, there's something called oxidation state. Oxidation state, right? Which is basically the charges, okay, of any element ions, okay, to tell what is happening, right? If it's losing electron or gaining electron. Okay. Now oxidation, as I said, right? As I said, that it is the loss of electron. It is the reaction which the element or atom or group of atoms will lose electron. So obviously, right? When we talk about atoms, ions, we can have, right, either three type of ions, so mainly three type of ions, okay, right, or complex compound, two types, either complex anion or ion or molecules. Now just think about it. Suppose you don't have any money, right, but you need money, so what you will do, right? And suppose you have to pay your landlord, so obviously you will ask money from somewhere, right? Okay, you will be in debt. Okay, you will be in debt. So suppose we have a neutral atom. You have a neutral atom, right? The charges on this atom, is zero because it's neutral. There's no charge, right? Now, if it is giving one electron, so obviously this atom, Na, will lose its electron. So charge will become plus one, right? The charge will become plus one, right? So or if I ask you, what is the oxidation state of this? Tell me, of this Na. Tell me, what is the oxidation state of this Na? Tell me, think everyone. Plus one. See, I'll teach you this chapter so that you don't have to mug up most of the things, right? I'll keep asking things, okay? Instead of teaching, I'll just keep asking. So this is plus one. Everyone is, like, everyone agree with this, right? Now, what about this Na? What was this Na? What is the oxidation state of this Na in the reactant? Tell me. Tell me, everyone. Zero. Yes, very good. Zero. Now, what do you think? What is happening to oxidation state? It is increasing or it is decreasing? Increasing. Yes, very good, right? So oxidation state is increasing. right? Clear enough, right? It is intuitive. It is intuitive, everyone. Now let's see. What about this Al? 0. What about this Al? +3. In this case also, it is increasing, right? So you might ask, okay, so this was the case of neutral atom. What about cation and anion? Let's see. Let's see about cation and anion. Now, just think about this, right? Logically think about this. If you are removing electron, then positive charge will increase or not? Tell me. If you are removing electron, then the positive charge will increase or decrease? Tell me. Will it increase or decrease? Yes, very good. Increase. Is there anyone who is not getting this? That how the oxidation number is changing, how it is increasing? Right? Everyone is getting this concept? Okay, very good, everyone. So I can say that in general, I can say that positive charge increases and negative charge decreases in oxidation. Yes or no? Right? Doesn't matter which anion, which cation, which molecule you are taking, right? Because if you're losing electron, right? If you're losing electron, then the negative charge will decrease and the positive charge will increase. Right, everyone? Right? Okay, so I hope all of you understood the modern theory of oxidation. Anyone have any issue in oxidation? Tell me. Anyone have any issue in oxidation? What is oxidation? Right? So, if you have to see that oxidation is happening or reduction is happening, you just have to check what? Oxidation number. Now we will see what is the oxidation number, how to find the oxidation number, right? But first we should talk about, we are talking about the definition, okay? That what is oxidation, right? Okay, very good. Now, reduction, as we said, right? As we said, oxidation was lose of electron, right? So the reduction would be gain of electron. Yes, so reduction is gain of electron. So what do you think? If you're gaining electron, right? If any atom or molecule is gaining electron, which charge will be increasing? Tell me, which charge will increase? Positive or negative? Negative charge. Yes, very good, right? Everyone is getting very good, Anjali, very good, Anamika, right? Sanya and Sneha, just write down the name of students who are absent because there are uh, 14, 13 or 14 students who haven't joined the second class. Okay, even though I messaged. Yes, negative. Very good, everyone. Right? So this is intuitive, right? Everything is intuitive. They're getting everything. Now, if the charge is getting added, right? If the negative charge is getting added, what will happen to oxidation number? Oxidation number. Will it decrease or increase? Will it decrease or increase? Yes, very good. It will decrease. Very good, everyone. Right? Very good. Right? So I can say that in reduction, positive charge decreases, right? Negative charge increases and oxidation number decreases. Okay, right? Easy enough. So these are the examples in neutral atom, right? After taking electron, it will become negatively charged anion, right? When you talk about cation, depending on how much electron it is taking, so either it become neutral or cationic or anionic, doesn't matter because it depends on what? Number of electrons it is taking. For example, if I'm talking about this Cr4 plus 2 electron, right? Gives Cr2 plus. Now tell me, what is this? See, both are cation, yes or no, right? But oxidation number is increasing or decreasing? Tell me, everyone, oxidation number is decreasing or increasing? Decreasing, yes, very good. So obviously it is reduction. Okay, got it? Right, everyone? Easy? So I hope all of you understood the modern concept of oxidation and reduction. Now, if you ask this, if you ask what is the next important concept, just think about it. Don't you think that, so we are talking about oxidation number. So we should know how to find oxidation number, right? Because if we don't know what is the charges before and what is charges afterwards, how can we say that it is gaining electron or losing electron? So the next topic is oxidation number, right? So how to find oxidation number? Okay, so oxidation number is actually oxidation number, right? We talk about oxidation number of individual element or individual atom. Yes or no? Tell me, right? Okay, or a group of molecule. So obviously there must be some standard oxidation numbers. Tell me, there must be some standard oxidation numbers. For example, if I talk about this atom, suppose I'm talking about Na, right? What can you say about Na? What is the general characteristics of Na? How much electron it gives or take? Tell me. Generally, normally, Na, sodium. Tell me. Have you heard that sodium is giving 2 electrons? Have you heard like that? No, right? Sodium, that's the thing, right? Sodium or most of the metals have their fixed, right? Usually, I'm talking about S block elements, right? So for S block elements, generally the valency is fixed. Yes. For example, when you talk about group one, okay. So group one, I can say that for group one, the valency is 1. Yes or no? The valency is 1. So be it sodium, potassium, right? Okay, so all of them will lose 1 electron, right? Tell me. So I can say that it is a fact that the elements of group 1 will lose 1 electron. So oxidation number is +1, right? +1, always. Agree? Yes or no? Agree? Right? So obviously in the same way, we have some rules of oxidation number that you should write and you should remember. Okay, what are the rules? Let's see. The rules are, right, for some elements, the oxidation number is fixed. For example, fluorine. Fluorine is highest electronegative atom. Yes or no? Fluorine is highest electronegative atom. So the oxidation number of fluorine is always -1. It is fixed. Okay, doesn't matter whatever compound is, the oxidation number of fluorine can never be anything other than +1. Okay, right? Now we talk about oxygen. So generally, when you talk about oxygen, right, just oxygen, the oxidation number is 2, right? Minus, it is 2 minus, so we just say that oxidation number is 2. Okay, right? Now when you talk about increase or decrease, you have to consider sign also. Okay, now but when you talk about different molecules of oxygen, for example, when you talk about O2 minus, wait, I just, for oxygen, normal oxygen, it is 2. When you talk about O2, now O2 will have two type of molecules. One is O2 minus, right, which is peroxide, and the second is O2, tell me, sorry, O2 minus. O2 minus is peroxide, second is O2 minus, which is superoxide. Okay, now tell me, when we talk about O2 minus, so I'm saying that 2 oxygen will have 2 negative charge, right? 2 oxygen. Yes, Aviram, message to host. So when you talk about just O2 minus, so I can say that oxidation number is 2 minus. When you talk about O2 2 minus, then what do you think? What is the oxidation number of oxygen? Tell me, what do you think? What is the oxidation number of oxygen here? Yes, very good. Because two oxygen have -2 charges. So per atom, per oxygen, we have -1 charge, right? So in this case, it is -1. Okay. What about superoxide? Tell me, what about superoxide? Yes. So two oxygen will have -1 charge. So one oxygen will have -½ right? Now there's only one case in which oxygen have +2, which is F2, because fluorine is more electronegative than oxygen, right? So in this case only, oxygen will have +2 oxidation number, right? So this is the fixed oxidation number which is possible for oxygen. Now, when you talk about hydrogen, so generally hydrogen, right? Generally hydrogen is seen as H plus, yes or no? Tell me. Generally hydrogen is seen as H plus, okay, right? But when we talk about hydrogen with metals, for example, NaH. Now, what do you think? When you talk about NaH, we know that for sure that the charge of sodium is +1. +1. What about hydrogen? What can it will be? Tell me. What can it be? Yes, meat. Very good, right? So this is fixed that it is +1, then this should be -1, right? Because overall compound is neutral. Okay? Yes or yes, very good. So in this case, it is called as hydride. Hydride. Okay. So hydrogen have two, tell me, hydrogen have two charges. One is +1, but in case of ionic hydrides, it is -1. Okay? Right? Now, what is the definition of metal? Tell me, what is the definition of metal? I hope all of you studied this in class 8 and 10th. So how many of you remember that metals are the elements which give electron? Yes or no? Right? Lose electron? Yes. So obviously, if metals are losing electrons, so they will always be positive. Okay? They will always be positive. Have you ever heard that CO2 minus? Tell me. Have you ever heard of CO2 minus? No, right? Got it. So metals are always positive. The oxidation number of metal is always positive. Okay, it might be 0 in neutral state, but it will be positive. Okay, then again, alkali metals, which is group 1, it will always be +1. Alkali earth metal, which is group 2, it is always +2. Halogens, always -1. Sulfur, right? And sulfide is always -2. Okay, sulfides, which is S2 minus, right? So these are some electronegative valence that we have to remember. Okay. For example, this is a general. I'm not talking about FCl or Fi kind of thing. It is in general when it is in with metals. Okay, right? Obviously, there will be exception like FCl. In case of FCl, it is F minus and Cl plus. Okay, right? So we are not talking about that kind of exceptions. We're just talking about the general term. Okay, everyone, got it? Because halogens are positive only when it is attached with high electronegative halogens. Okay, not generally. Okay, same can be said with sulfur, but obviously it is not your general reaction, right? Now there are many other rules also, but these are the basic rules. Now, second is how to find. How to find. Now let's see this, right? Let's see this. Okay. Now, let's see one example, right? Let's see the example of KMNO4. KMNO4. Okay. Now tell me, out of this, how many elements do you have? Write down all the elements. K, Mn, and oxygen. Step by step. Everyone try to understand step by step. Okay. Now, what do you think? Out of these three, whose oxidation number you already know? Potassium, we know it is +1. We already know that, right? Yes, very good. Oxygen, it might be -2, it might be -1 also, but I'm taking -2 only. Okay, right? Now just find what is the total charge of KMnO4. Tell me. Total charge of KMnO4 is 0. Yes, yes or no? Yes or no? Tell me, everyone. So if I use the basic equation, if I use the basic linear equation in one variable, which is charge of potassium, which is +1, plus charge of Mn. Suppose charge of Mn is x plus 4 into charge, because oxygen is 4, right? 4 into charge of oxygen, which is -2, should be equal to 0. Agree? Step by step, everyone. Step by step. Agree, everyone? Tell me. Step by step, everyone. Are you getting this? Tell me. Yes, are you getting? Very good. Now, can you find the value of x? Can you find the value of x? Very good, Meet. Very good. Meet, calculate once again. Very good, Anamika, Anisha, Siddharth. Very good. Yes, very good. So if you solve, you will get x is equal to 7. Okay, right? So what do you think? What should be the charge of Mn? It is plus 7, right? Plus 7. Now just think about this. If I'm saying that I'm having a reaction in which K, any reaction in which KMnO4, KMnO4 is converted into MnO2, MnO2. Now tell me, what is the charge of Mn in MnO2? Tell me, what is the charge here? What is this Y? Tell me, what is this Y? Everyone, tell me, what is this Y? Yes, OS, Abhiram, very good. Everyone, tell me, in MnO2, again, step by step. Very good, Ria, very good. Very good, Sanya, sorry, Samya. Samya, you are login with Madhur's name, so I might, yeah. Very good, Meet. Very good, Anamika. Very good, right? So all of you are getting this is very easy, right? Y plus oxygen is 2. So 2 into minus 2 is equal to 0. So y is equal to 4. So this is Mn plus 4. Now tell me what happened here? Tell me. Yes, very good, Amish. Very good, Riya Singh. Raja, both. Right? I'll just call it Riya 1, Riya 2. Okay, because when I say Riya, right, you might get confused. What do you think? What is happening? Very good, Soumya Lakshmi. Very good. Very good, Riya. Very good, Anamika. Anamika, check. Oxidation number is increasing or decreasing? Check this. Decreasing, right? It is decreasing now. It is gaining electron, right? Very good. It is gaining electron. Okay. So gain of electron is what? No, Abhiram. Wrong. It is gaining electron now, right? Oxidation number is decreasing. So it is reduction. It is reduction. Yes or no? Gain of electron. Right, everyone? Tell me yes or no. Now I hope all of you are getting how to identify, right? Let's see some more problems, right? Let's see one more problem. Okay, now tell me about this. K2Cr2O7, right? And CrO3. Tell me, what is the oxidation number here? Tell me. Cr32 minus. Okay, let it be Cr32 minus. Find everyone. So obviously you have to find for Cr, chromium, right? Try to find everyone, try to find. Yes, very good, very good. So very good. So just step by step. Potassium, chromium, oxygen, right? Potassium plus 1, chromium doesn't know X, oxygen minus 2. So 2 into 1 plus 2 into X plus 7 into minus 2 is equal to 0. So 2 plus 2x minus 40 is equal to 0. So x is equal to 6, right? Now in this case, okay, in this case, again, CrXO2, so X plus, right, 2 into, sorry, 3 into minus 2. Now overall charge is minus 2 here. See, overall charge is minus 2. It is not minus 0, it is minus 2. So minus 2. So X will be minus 2 plus 6. So X is equal to plus 4. Right? Got it, everyone? 6 and plus 4. How come you are getting 13, Meet? How come you are getting 13? Right? Tell me. Now, in this case, what is happening? Oxidation or reduction? Yes. See, everyone think about it. Oxidation number, right, will always be less than 8. Okay, it will always be less than 8 and greater than minus 8. Oxidation number will always be in between this number. Okay, right? Right? So see this. In this case also, if it is converting from plus 6 to plus 4, right? It is accepting electron, gain of electron, right? It is reduction. Right, everyone? Plus 4. Okay? If it is converting from plus 6 to plus 4, decrease in oxidation number. Just think about this. Decrease in oxidation number. So, reduction. Anyone have any issue? Tell me. Tell me, everyone. Is it clear to everyone? Samya, Akshaya. Akshaya, it is reduction, right? Okay, very good, Samya. Very good, Anamika. Okay, right? So, yes. Let's see some more examples. Okay. So these rules we have already studied, right? Now, what about, so you can ask me, so what about this Mn? Mn is also metal, right? Mn is also metal, Cr is also metal, but the charges, right, or the oxidation number is changing, right? We saw that Mn had plus 6 or plus 4, right? Same with chromium, it was plus 6 and plus 4. So the oxidation number of changing, yes or no, the oxidation number is changing, right? Why is it so? So if you actually remember your periodic properties, right? These metals are D, yes, D block elements. Yes or no? Tell me, they are D block elements. Okay. Now, when you talk about D block elements, they are called a transition element. I hope all of you remember in periodic properties that they are called transition elements. And at that time, I told you why they are called as transition elements. Tell me, yes or no? How many of you remember? Just raise your hand. How many of you remember? Right? Very good. Most of you remember, right? Very good. Yes. So D block elements can have different oxidation number, right? Because of, yes. So because of that, they are called as transition element. Okay, right? Got it? Now, there are some P block elements also which have variable valency because of what? Covalency, right? Covalency. I hope everyone remember the concept of covalency also, right? Everyone remember the concept of covalency also? Okay, very good. So see, these are some general valency which is possible. For example, for first group, right? For first group, possible is, tell me, +1. For second group, +2, right? So you might be thinking, so how to know that what can be the maximum and minimum possibility? Now just think about nitrogen. Just think about nitrogen. Okay, right? If you don't accept D block elements, see, we didn't talk about D block elements. We talked about, tell me, we talked about which group? S and P. Now just talk about oxygen. Now oxygen, right? Now when you talk about oxygen, I said that any element can have oxidation number which is less than 8 and greater than -8. Okay, right? Now if you see oxygen, Oxygen. It have how many electrons? Tell me, it have how many electrons? 6 electrons in the outermost shell? Yes or no? Tell me. 6 electrons in its outermost shell, right? So it can either have 8 electron in outermost shell or it can have 0 electron in outermost shell. Agree? Tell me, agree? No formula, nothing. Just concept, just intuition. Agree? Now tell me, in order to get 8 electrons, it can either accept 2 electrons, right? So it can be -2, right? And how many electrons it can give? Tell me, how many electrons it can give? 6, right? So +6. But oxygen will not show +6 because obviously it doesn't have valence D block elements. But again, I'm not just talking about oxygen, I'm just talking about every element of this group, right? For example, sulfur, right? Just take example of sulfur, right? So I hope sulfur, you can relate. Sulfur oxidation number vary from -2 to +6, right everyone? Yes or no? Yes or no? Yes. So sulfur belongs to this group, right? 16th group. So see, it can, tell me, 0 plus -2, right? +4 and +6. Agree? Tell me yes or no. Yes or no. Now you are getting, right? Even if you don't remember, how can you calculate? For example, 15th group. 15th group have 5 electrons. For example, phosphorus. So it has to reach either 8 or 0. So in order to reach 8, it will give, so it will take 3 electrons. So minimum covalency, right? Minimum oxidation base -3. And it can lose 5 electrons, so +5, right? See, +-1, +-3, +-5, not -5, +5. So I hope all of you remember that when we talk about covalency, right, or any change, okay, for p block elements. So these are p block elements, okay, right? So if it has, yes, got it. So I hope all of you understood how to do this. You don't need any formula. Yes or no? Do you need any formula now? Tell me. N-8 or N-12 something, group minus something. No, right? No formula needed. Just basic concept. Okay? Right? Okay, very good, everyone. So tell me, can you know what can be the equivalency or valency of any elements of S block or P block? Tell me, yes or no? Right? Yes, you can know that. Very good. Okay. Now, chemistry. Chemistry is full of exceptions. How can chemistry be complete without exceptions, right? Chemistry cannot be complete without exceptions. So let's see the exceptions. Now, this is the most tedious thing, but even though these are exceptions, it can be understood, right? Now, what are the exceptions? As Abhiram said, that the halogens can have positive oxidation number. We saw that, right? Just see the oxidation number of this 17th group, which is the halogens. Now, halogens have 7 electrons in the outermost shell, right? It can either get 8 or 0. So, in order to get 8, it has to accept 1 electron, but in order to lose, right? In order to get to 0, it can lose 7 electrons. So, the oxidation number of halogen varies between +7 to -1. Yes or no? Yes or no? Right? So if we have any high electronegative atom with halogen, it will lose electron and it will form positive oxidation number, right? So do you think that this exception is more of concept? You can understand that? Yes or no? Tell me yes or no, right? Agree? So exception 3.2, all of you understood? This is just the concept that we studied right now. Got it? Tell me. Okay, everyone is getting this? Very good, everyone. Right? See, that's the thing, right? I try to teach every concept till that point that you guys understand, but you have to revise and practice. Now, for radicals, right? What do you mean by radicals? Radicals means, tell me, it's a molecule or charged molecules. For example, SO3, 2 minus, right? So you have to remember. Okay, you have to remember, right? So I hope all of you, especially those who studied with us, remember these. Language of chemistry, I told you why this is very important. We'll continue using till class 12, right? How many of you remember this from language of chemistry, right? So these you have to remember, okay? The name, especially the name, the valency and the symbol, okay? So most of you who are with us, they might have known this, okay? You have to remember, right? Got it? New students, you have to remember, write down these compound names, okay? Right? And you have to remember, for example, this is sulfite, this is the name, right? You can't argue that why this is sulfite. It is sulfite, it is the molecule or the radical which is present. You can think of the charge, why it is -2. You can think of that. How? Right? Now, SO3 -2. Now, it is -2. It is predefined, right? Because if it's not -2, you cannot argue because SO3, it is possible +6, -2. It is possible, right? But it is not like that, okay? It is -2, which means SF +4 only, okay? So these are radicals, some radicals that you have to remember, okay? Got it, everyone? An oxidation number of complex compound, right? Let's see. See this. The fourth one. Sorry, sixth one. Complex compounds. Now, when you talk about complex compound, okay, for now we won't be worrying about that because this chapter is in class 12. But how to do that? Same way, right? You should know the charge of any other radical. For example, H2. What is the charge of H2? Tell me. What is the charge of H2? Tell me, everyone. 0, right? Charge of H2 is 0. Yes, very good. And what is the overall charge? What is the overall charge? Overall charge is +3. +3. So I can say that x plus 6 into 0 is equal to +3. X is +3. As simple as that. Okay? Got it, everyone? Right? So point 1, 2, 3, 4. Okay, especially point 1, 2, 3. You have to remember. Remaining we have already covered. Okay? Now, let's see. I've already told you the method, right? So just verify this. Can you solve these by yourself? Can you now understand how we have the oxidation number of sulfur, right, is different in different compounds? Tell me. We have just discussed this, right? How to do this? I hope now it is clear, everyone. Right? Shreya is here. Shreya, are you getting everything? Pritam, Nidhi, Pradyumna, very good, right? Okay, very good. Now, in the same way, this is for sulfur. This is for sulfur. In the same way, we can have different oxidation number for phosphorus, for nitrogen, right? Right. So they are the examples. Just see this. This is for phosphorus. Now, we will try to solve one. Mg2P2O7, right? Try to solve this. Try to find the oxidation number of Mg2P2O7. So obviously, right, we have Mg, we have phosphorus, we have oxygen. Now Mg is second group element, which is +2 fixed. Oxygen -2. What about phosphorus? Tell me, everyone. Tell me. Yes or yes? Oh, Abhiram, Siddharth, very good. Everyone try to find very good meat. Pradyumna, it is P2. Remember, it is P2. So you have to find per phosphorus. Yes, Soumya, very good. Yes, Samya, very good. Pradyumna, very good. Anamika, very good. All of you getting? Very good, everyone. Anjali, are you getting? So it is 2 into plus 2, right? Because Mg plus 2 into x, right? Plus 7 into minus 2. Now this is equal to 0. Overall charge is 0. 0. So 4 plus 2x minus 14 is equal to 0. So x is equal to 5. Very good, Anjali, right? Very good. So I hope everyone is getting how to find. Tell me, right? Okay, right, everyone. Now try to find this one. We just discussed. Wait, sorry. We just discussed this, right? We just discussed this. That's why I'm just asking that how many of you are paying attention. Okay, find for hydrogen in H2S2O7. Tell me H2S2O7. Let's see who can solve H2S2O7. Okay, very good, everyone. So hydrogen, sulfur, oxygen, plus 1, minus 2, x. So 2 into 1 plus 2 into x minus 2 into 7 is equal to 0. So 2x is equal to 12, x is equal to 6 plus 6. Very good, very good, very good, everyone. Right? Very good. Okay. Now what about H2S2O8? Tell me, what about H2S2O8? Tell me. Again, Sanya, Soumya, don't make the mistake. Right? Ovas, don't make the mistake. What I just said, I said that sulfur, right, can have oxidation number between -2 and +6 now, right? Right, everyone? Just think about this. This is the concept. It can have between -2 and +6 only. How can it have +7, right? No, it cannot have +7, right? Then you should ask, so what's the difference then? What's the mistake? Mistake is this oxygen, right? If the oxidation number, right, if the oxidation number with calculation is more than what it should, it means there is some peroxide. Yes or no? There is some peroxide. Okay, got it? Tell me, everyone, right? So if you remember the structure of H2S2O7, if you remember the structure of H2S2O7, right, it was like this now. H2S2O7, right? Wait, this was double bond. Wait. I have made some mistake which I will show. Okay, right, everyone? right? Everyone remember this? This was the structure of H2S2O8. We have studied this in chemical bonding. Okay, so whenever and what it should, there must be some peroxide. Okay, that you should remember. Okay, right, everyone? Tell me, right? Okay, everyone. Very good. So, see this. Now, oxidation number of this is oxidation of sulfur, phosphorus, again chromium. So you don't have to remember, right? You don't have to remember. Okay, you can calculate easily, yes or no. Okay, let's solve one more. CrO to Cl2, chromyl chloride. Okay, CrO to Cl2. It is called as chromyl chloride. Very good, Soumya. Very good. Right, so I guess all of you are getting it now. X plus 2 into minus 2 plus 2 into minus 1 is equal to 0, 6. Now tell me, can you find the oxidation number of anything now? Any compound? Tell me. Yes or no? Just raise your hand. Right? Easy? Okay. Now, what about this compound? Tell me. HN3. Tell me, what about this compound? HN3. Find the oxidation number of HN3. Of nitrogen, obviously. Tell me, everyone. Yes, Pranjal, very good, right? Very good. Ovas, see, out of these two, which is your high electronegative atom? Now, whenever you have these kind of compound, right? Just see N, triple bond N, single bond H. Now tell me, this is actually HN3, right? Right? Okay, right? So if you calculate using the formula, it will be, tell me, minus 1 by 3, right? Which means this minus 1 charge is distributed over all the 3 nitrogens, right? So we will see these are called as fractional, okay, fractional oxidation number, right? So after chromium we have manganese. So I hope all of you can calculate. You don't have to remember what is the oxidation of number of manganese in KMnO4 or K2MnO4, right? You can calculate. Now, if you see this, if you see the oxidation number, right? For manganese, it is 0 to +7, right? 0 to +7. That is something you have to remember, right? For manganese, it is 0 to +7. For chromium, it is 0 to +6. Okay, this is something that you have to remember. That's it. Okay. Now, I hope all of you remember the valency. What's the definition of valency? So if I ask you, is valency oxidation number same? No, right? Obviously, no. Valency oxidation number, right, is not same. Okay, right, everyone? Tell me. Okay, everyone. So I hope all of you understood the basic difference between valency and oxidation number, right? Valency is the electron, the number of electron which it can give or take. It is combining capacity, right? It is the combining capacity. It doesn't have any sign, positive or negative, right? Got it? Whereas oxidation number is the, tell me, charge, real charge, right? Which is either plus or minus. Okay? Now valency is usually fixed, but oxidation number can change, right? Formal charge, there's no difference between formal charge and oxidation number. You can just say that formal charge is oxidation number. Okay, right? Got it, everyone? Tell me, got it? Yes or no? Tell me. Till this point, anyone have any issue till this point? Till anyone have any issue till this point? Clear? Okay, very good. Now the next, after knowing oxidation reduction, right? The next term is oxidizing agent and reducing agent. Now just think about it. Just think about it, right? Suppose we have an element A, right? And element B. Now just think about this. If element A is giving electron to element B, so element B is taking electron from element A, yes or no? Yes or no? Right? It's simple. So what is happening to element A? Element A is giving electron, right? Loss of electron. So element A will go through oxidation and element B is taking electrons. So it will go through reduction. Simple. Tell me, till this point, everything is clear? Tell me, everyone, right? Okay, very good. Now, what do you think? If this is oxidation, who is responsible for this oxidation? Tell me, who is responsible for this? Who is responsible for A to lose electron? Tell me. Tell me, everyone, who is responsible for A to lose its electron? B, right? Agree? B. So can I say that B is oxidizing agent? Because it is B is making A to lose its electron, right? So B, can I say that B is oxidizing agent because it is oxidizing A? Yes or no? Tell me, yes or no? Tell me, yes or no? Right? Very good, everyone. Now, can I say the same thing about A? That A is actually responsible for reduction of B, right? So A is your reducing agent. Okay, right? So just have to remember that any element or compound or ion which undergo reduction is your oxidizing agent. Okay, and which undergo oxidation is a reducing agent, because it is making any other compound, elements or atom to oxidize or reduce. Got it? Tell me yes or no. Yes or no? Tell me, everyone, raise your hand. This you got? You just have to remember this or understand this. Everything else will be clear. You don't have to like worry about different definitions. Okay, just see this, right? If I'm taking electron, so obviously I'm making someone to give electron now, right? I cannot take electron from nowhere. Okay, so obviously for that person, for the other person, I'm oxidizing agent, right? And for me, the other person is reducing agent, right? Okay, got it, everyone? Tell me yes or no. Yes or no? Everyone got this? Very good. Now let's see. Let's see this. Now think about this. If any element, element is in its highest oxidation state, think about it. Highest oxidation state, right? Means it cannot give any electron any further. Then tell me, will it be a good oxidizing agent or good reducing agent? Tell me. If it is in the highest oxidation state, means plus charge highest. So it has tendency to gain electron and lose electron. Think about it. It will have tendency to gain electron and lose electron. Message everyone. We have 12 minutes left. We'll take class till 1:30. Gain electrons. Very good. Now, if it is gaining electron, right, it will be oxidizing agent or reducing agent. Think about it. Gain electron, reduction will occur. So it will be oxidizing agent, right, everyone? Right? Got it? Yes or no? Yes or no? Now, suppose we talk about any compound in which Cr is having +6 oxidation number. Can it behave as reducing agent? Tell me. Can it behave as reducing agent? Yes or no? Just think about it. If we have a compound in which the oxidation number of chromium is +6, can it behave as oxidizing reducing agent? Can it take more electrons? Like, can it lose more electrons? Yes, very good. So it cannot behave as reducing agent. It will be very good oxidizing agent. Yes or no? Tell me yes or no. I'm teaching the concept so that you don't have to mug up anything. Okay, right? Right, everyone? So obviously, if oxidation number is decreasing, right? If oxidation number is decreasing, means reduction is happening, means it is your oxidizing agent. Zinc agent. Got it? Right? Now just see this example. See all the examples, right? Oxidation number decreasing, decreasing always, right? Decreasing, right? If oxidation number is decreasing, so it is your oxidizing agent. Agree, everyone? Agree? Tell me. Understanding this concept? Right? Okay, very good, everyone. Right? Now, the same thing can be done for reducing agent. Same thing can be done for reducing agent, right? See, these compounds you can just remember because we will use these compounds in organic. For example, right? These all are oxidizing reagents in organic, okay? So you should remember, okay, that these compounds are generally organic. We will study this in organic